Hello and welcome. My name is Matthew Tucker and I'm Pittsfield Community Television's Engagement and Experience Coordinator. You are currently watching a part of the PCTV production training series, Production Foundations. The goal of the Production Foundations series is to teach you the basics of the concepts of video and audio and give you a background for future training sessions that you'll have in person at Pittsfield Community Television. This first session is going to be focusing on video basics, so the concepts of what video is and how it all works. The goal of this session is that we want you to learn what video is and how it functions. We'll study how a camera physically works. You'll want to understand image control features on a camera and how to use them. You'll master the 6 basic camera commands as may be given by a production director. And you'll learn some basic composition, including the rule of thirds. So let's start at the very beginning. What is video? Video is a magic trick. It's an illusion. It's not actually motion. It's a simulation that has been developed over the years by people far smarter than I to create the effect of motion and trick our brains into seeing moving pictures. But what is happening is it is literally moving pictures, actual still photographs moving at a high enough speed that your brain blurs them. These photographs are called frames. Because the logic behind photography gets used in video, some of the concepts that apply to photography will also apply to video. So if you're familiar with photography at all, or you've heard photography terms used in the past, you'll recognize some of what we'll talk about today. A key thing to sort of set is at certain times, I will refer to various pieces of recording equipment, specifically a camcorder. It's a term that you've heard a lot, but I bet you wonder what it means. Camcorder is 2 words smushed together: camera, recorder. It's a device that mixes together video and audio into a single product that you can then turn into some sort of content. During a future session, we'll talk about audio. We'll be focusing today, as I said previously, just on video. So I talked about those individual pictures. We call those frames. And there is a little bit of science that's been done that we'll touch upon in just a moment to figure out what works as far as moving pictures in order for it to make sense to our brains. But a term that you'll often hear in relation to video and frames is something called the frame rate, or frames per second. That is a term that describes the speed at which literally the number of little pictures that you see over the course of a second of video. This is important because for knowledge purposes, you may be coming across several different video formats in your experience. Film, for example, is equivalent to 24 frames per second. NTSC format, which stands for National Television System Committee, the group in the United States that developed the speed at which video functions, decided on 30 frames per second. Phase alternate line method, or PAL format, which is used in Europe and other European regions, uses 25 frames per second. The reason for that, and some of the logic and science behind all of that works, I'm going to have explained by one of those people who's far smarter than me. There's a fantastic YouTube personality by the name of Captain Disillusion. Most of what Captain Disillusion does is he debunks video illusions and videography tricks. But one of the things that he wanted to get into was to teach people the mechanics of video. And he, much better than I can, describes what frame rate is. So we're going to take a quick break and have Captain Disillusion explain to you what frames and frame rate are and why they function the way they function.
This is a still picture. This is a slightly different still picture. If we switch between them quickly, it kind of looks like I'm moving. If we add more pictures, it starts to look like realistic motion. That's how animation works, but it's also how anything moves on screen. The pictures don't have to change that fast for us to perceive the illusion of motion, but somewhere around 20 a second makes it feel less annoying when watching for long periods. And the pace doesn't have to be perfectly even, but if we want the recorded movement to play back at its natural, real-world speed and stay in sync with other things, like sound, it helps to keep the frame rate constant throughout the process. A long time ago, the entire world settled on 24 frames per second as the standard for motion pictures. It wasn't too hard to control the speed of film cameras and projectors by governing their motors with crystals. But the invention of television transformed moving images into electrical signals, so electricity itself had to keep the frame rate steady. This was done by distributing the frame information evenly into the cycles of alternating current. In parts of the world where AC power modulates at 50 Hz, the frame rate was adjusted to 25 frames per second. Places where it modulates at 60 Hz had to raise the frame rate up to 30, which looks like this. And for one place, the introduction of color to video caused slight interference with the audio signal, which showed up as occasional dots for those few still watching on black and white TVs. So of course, the government slowed down the broadcast frame rate by 0.1% and keeps it that way to this day. Which is weird because the reasons for this awkwardness are long gone. Wires and radio waves no longer carry raw analog signals, but packets of digital information. Everything about the picture, including the frame rate at which it should be played, is bundled along and decoded by the device showing the video.
So you can see, based on Captain Disillusion's explanation, what frame rate is and how frame rate was determined. Film, it was super easy. Film used actual film similar to what people used in traditional film cameras. So these frames were actually photographic still images that would go through at a specified rate based on the rate at which the film was moving. Whereas video with electronic elements had to change the rules in order to match electricity. So there are a couple of concepts that are tied into frame rate when you're talking about video. Those concepts include resolution and the ideas of video that's interlaced or progressive. Once again, Captain Disillusion does a fantastic job describing the difference between what pixels are and how they function and what the history of them is. But I wanted to take a moment to define interlaced versus progressive so that it isn't such a weird and unusual concept as we jump into it. Very often you will see resolutions having a letter next to them, letter I or the letter P. Those indicators will tell you whether the television or video device that's doing the interpreting uses interlaced or video or progressive video signals. So old-fashioned TVs, before we got our flat screens, used to require interlaced video for a reason that we're about to learn. And eventually we were able to do progressive video. And the concepts are important because you may work, especially if you have older video equipment, with something that's interlaced and mix it together with something that's progressive. So to understand what those are and what I'm rambling about, let's go to Captain Disillusion and learn a little bit more about pixels, resolution, and interlaced and progressive.
We kind of got into television before it was finished being properly invented. Broadcasting started in the 1930s, but the first flat-screen displays that could show moving images in a normal, contiguous way didn't appear until almost the 21st century. Before then, humans had to make do with the cathode ray tube. In a CRT display, an electron emitter shot a stream of electrons at your face, but there was a screen in the way, and the whole thing was in a vacuum tube, so the electrons didn't bump into air molecules. The TV transmission was decoded as fluctuations in the intensity of the electron beam, and as it traveled forward, magnetic coils on the sides of the tube deflected it to scan in a horizontal pattern down the screen. This rapidly drawn pattern of lines, called the raster, generated the video image. Some parts of the world went with 525 lines, others with 625. Doesn't matter, it's not a competition, because if it was, Europe would be the winner, and anyway, this was just vertical resolution. Analog television didn't really have horizontal resolution, since those electron fluctuations across a line were continuous. But electrons themselves don't look like much. In order to make them visible, the screen was covered in a pattern of phosphor dots, which lit up when bombarded by the electrons, then dimmed back down on their own. And this was an issue. All this glowing and dimming had to happen instantly, over and over, at a constant frame rate, as high as 30 per second. You couldn't use phosphors that glow longer than a frame, because then the next frame couldn't be drawn in time. But when they dim fast, as every consecutive line of the frame gets drawn, the gap before the next one is too long for persistence of vision to handle, which in real time means flicker! The solution? Draw every other line to get across the raster in half the time, then go back and draw the missing lines in a second pass. That way the refresh rate is doubled, and even though only half the resolution of the image is on screen at one time, the swap is so fast that persistence of vision makes it look like a full resolution frame.
So now you understand the concept behind interlaced and progressive. So interlaced video using the cathode ray tube used to be, as the term describes, interlaced. The electron beams would hit the row of pixels that were odd numbered, so 1, 3, 5, and would run all the way down the screen in a second, faster than a second, in a frame, a 1/30th of a second. And then a second set of beams would hit all of the odd pixel lines, 2, 4, 6, 8, and that would repeat every frame. Progressive video doesn't need to do that anymore because modern video screens don't require that electron beam to go through the pixels. It just displays images on those small pixel elements, pixels, to allow you to see your video image. So progressive video functions progressively, 1, 2, 3, 4, 5. The reason that that is important is if you're ever working with older camcorders and newer camcorders and putting the content together, you'll notice that older content has these sort of wavy lines in them. That is an effect of interlaced video. You are seeing a progressive screen trying to figure out how to make those wavy lines work. So there are some tricks that can be done to figure all of that out in the editing process. But it's important to know when that comes along because there are all sorts of rules when you're making video about how the camera records, because the camera can record in interlaced with those wavy lines. The camera can record in progressive with all of the lines stacked up numerically. So when you're setting things up, you want to make sure that the camera settings are correct, either I or P for interlaced or progressive. You'll also usually have a resolution number before that letter. The resolution number tells you how many pixels, sort of like a megapixel size of a photograph, how many pixels by a large factor number. The horizontal measurement of the camcorder is recording. Full quality HD video is 1080, so 1080 pixels from the top to the bottom. Less advanced HD, sort of half HD, you often see it in sports because it does motion a little bit better, because it can run a little bit faster at a higher frame rate, is 720, so 720 from top to bottom. As mentioned before, there are different formats for standard definition, older televisions, based on whether you're working with the NTSC video or the PAL video. So knowing those numbers and what they mean is important when you're setting up the camera and making sure all of your settings are correct. Most of the time, for a modern camera with a modern editing situation, you want to make sure that your camera is set to 1080p. That is the highest quality for the camera to record, and the highest quality that most televisions can broadcast. We do have cameras that are capable of 4K, which is considered a film format. That's 4,000 of those pixels from top to bottom. But most televisions don't have cable in that format anyway, so sticking with HD works for almost all applications. So you want to make sure your camera, again, is set to 1080p, because that will give you the most consistent, most modern, cleanest looking video format. All right, so you've got all your settings correct, you've got your frame rates figured out, you've got your resolution managed. Let's talk about how a camcorder works. So there are various elements to a camcorder. Light from outside the world enters the camcorder, and the camcorder in some ways functions like a human eye. It has a lens that allows it to focus and adjust the nature of the light entering into it, so that the operator of the camera can communicate what they want to communicate with their content. The light goes through a series of glass lenses and then goes through an iris, an aperture, an element that controls the amount of light that goes into the sensor on the camera, which is the element that converts that light into electrical information. It used to be that your iris and your aperture were elements that would strike a piece of film. But now modern cameras all have electronic components, so there is a sensor that simulates that film that creates electrical signals or digital signals that allow the camcorder to create a bit of video content. So when you're talking about lenses, there is a concept that you will often hear in photography called focal length. We in video often consider focal length to be connected with the zoom capabilities of the camera, because the focal length is a big fancy word for the amount of the world that the camera lens allows the image sensor to see. I've got a diagram of what focal length is. You'll see a camera on the right-hand side and a range of sort of rainbow images showing different focal lengths of a camera. So a 35mm camera has different focal lengths based on different lenses. We don't often talk about focal length when we talk about video because we're thinking about zoom and the magnification multiplier of the zoom lens. So a zoom lens will often have a number such as 10x or 20x. So you can see up to 10 times your physical distance away, or 20 times your visual distance away. Focal length communicates this in millimeters based on photography rules. So a wide focal length with a small millimeter number is able to see a lot. And fisheye cameras have a very sort of shallow focal length. They can see everything around you, and it's sort of an unnatural visual. As you tighten your focal length, you see less of the image, but you see farther in front of you. So when that focal length is bigger, say 80 millimeters, you're able to see farther away, and those millimeter numbers are based on distances of lens components inside the camera. I mention all of this because, again, with video and photography being so closely tied, you may hear the terms of focal length, particularly if you're using a video camera that's also a still camera, such as a DSLR. So knowing that focal length and zoom are interlocked concepts is important, because you want to understand the history and the logic behind all of the elements in the camera and how you're getting closer and farther from your subject. So in addition to a camera's focal length, well, we're talking about lenses. Older cameras, particularly when they were working with film, would have a shutter in them, just like a still camera would. The function of a still camera, for anyone who's not familiar with it, there would be a piece of light-sensitive chemical material, a piece of film, that would be placed in front of the lens, which would get an image. And then a shutter would, for a fraction of a second, open up to allow light to touch that photosensitive chemical strip. And then the shutter would close again to allow the light to imprint on the film. So a shutter speed would determine how often that shutter would open and close and put images on your piece of film. The concept continues in digital cameras, although the cameras do all of that electronically now. So very often there isn't a physical shutter opening and closing. It's a digital process that gets simulated by a little computer in your camcorder. But understanding what the concept is important, because it affects the way the image functions. So shorter shutter speeds. So again, thinking about that mechanical shutter, open, close, open, close. It would open for a little bit and only let a little bit of light in. So a quick shutter speed isn't going to give you an image that's really bright, or it's an image that needs a lot of light, like being in daytime or in an extremely well-lit room. But a quick shutter speed gets you very sharp detail. So quick shutter speeds were key and are still key in recording sports. So sports is people running and moving and being quick, and you want every single frame to be crystal clear and sharp and gorgeous. So, and very often, either sports events are held during the daytime or in an extremely well-lit stadium that might as well be daytime. So a quick shutter speed doesn't need to put a lot of light into the camera, and it gets really nice, sharp images. Longer shutter speeds open slower and allow more light to get into the camera. And those are great for situations where things are darker. if you're in a situation where you cannot control the light in a room with no windows or at nighttime without a lot of additional light in the area, a slower shutter speed is going to allow more light to get into the sensor of the camera. But when you open it more, there's going to be blur, and if there's motion, things sort of get fuzzy. It's useful for situations where there isn't a lot of quick movement, or you definitely need to get your subject well lit. Night sky photography is a great example of a longer shutter speed being applied, because that slow shutter speed lets the light of the stars get into your visual sensor and allows you to have something that's meaningful and beautiful and creative. Balancing your shutter speeds is important, figuring out what sort of environment you're in. Is it a bright environment? Is there a lot of quick motion? Is it a dark environment? Are people not really moving? Modern cameras will very often adjust shutter speeds on their own. So this is not something you necessarily need to be thinking about, but knowing what shutter speed is and what it does allows you to set the camera to manual and control it yourself if you're not happy with what the camera comes up for you. Another setting that the camera can control on its own, but it's good to understand, is the concept of iris. So the iris is very similar to the iris of your eye. There is an element that opens and closes to let more or less light from the environment in. And again, the iris and the shutter speed were connected, because if you closed the iris but slowed the shutter speed down, you could balance out that light and motion problem that we were discussing before. So the iris is the mechanical part of the camera that's opening and closing, similar to your eye. Sometimes you will hear the term aperture used in photography. Aperture and iris are directly connected because they use the same mechanical piece in the camera. The aperture is similar to your pupil. It's the size of the hole that's in the iris. When people talk video, they'll talk about adjusting the iris. When people talk photo, they'll be talking about adjusting the aperture. The thing they're adjusting is the same. So now you know those terms are analogous, and while the concepts of how to adjust them can be tricky to sort of wrap your brain around, you won't be talking different languages if you hear those terms. Adjusting that iris, again, allows more or less light into the camera. And in photography terms, you'll hear the size of the aperture displayed as an f-stop. So if you take a look at your camera and you're looking at a viewfinder, you may see f/ and then a number. The example that I have on my slide is 1.6. The size of the aperture is inverse to the size of the number. So big number, smaller aperture. Again, that's not as important to know when you are dealing with a camera that's set up to do things manually. But in a studio application, you may have an instance where you need to make a camera brighter and communicate to your studio engineer that some adjustments need to be made on the camera. And very often, settings such as shutter speed are set on the camera for the studio environment, but your engineer can control the iris and allow more or less light into the camera. So knowing what the iris does can be important in a lot of instances, even though it's not necessarily something you directly control. Another element that comes into cameras and is very important in regards to the lens is something called depth of field. Depth of field is the amount of space that the camera can see in focus. So, and I have a fantastic diagram that I'll show you that explains this a little bit better. But visually, we've gotten used to different rules when it comes to depth of field and how it looks and how it works. For example, if you see someone in a portrait, usually they are crystal clear, but everything behind them is blurred so that they really pop off of the photo. That is a camera with a shallow depth of field. There's only a small space in the area in front of the camera that is in focus. Something with a wide depth of field has lots of stuff that is in focus. Very often, camcorders are designed to have wide depths of field so that you can very quickly pick up your camera and get everything in focus and not have to worry about whether things are blurry or not. However, there are instances, for example, film or other creative content, where you want to control the amount of space that's in focus or not. So knowing what depth of field is important. And also knowing that when you adjust your iris settings, it affects your depth of field. A lot of camcorders don't tend to have elements in them that when you're messing with your iris, it dramatically changes your depth of field. But it is something that when you're making those adjustments, it can change the amount of what's in focus. And knowing that that's happening is important, that if you're manually adjusting your iris and all of a sudden something goes out of focus, it may be that your depth of field has changed. Again, a lot of the camcorders that we have here at Pittsfield Community Television allow for what's known as run and gun. You want to grab your camera and record a subject and have it be crystal clear and not have to think about setting up your focus ahead of time. It's important for news or other events where you've got to move quickly, or you may not have a tremendous amount of photography experience. You just want it to work. So camcorders are designed to have a very wide depth of field so that you have that experience. There are some camcorders, such as the one that I'm holding now, that are designed to have a little more depth of field, as well as DSLRs and specialized lenses that shorten that depth of field. And I keep saying that. And depth of field, you keep saying that, but I don't know if I know what that means. So here is a great display of what depth of field is. In the subject on the top, you can see that there is, on the little sort of measure on the bottom, there is a shallow area where the camera is able to focus. So the person that it's focused on, the person in the foreground, is in focus, but the background, the tree, is out of focus because it's out of the depth of field. The option on the bottom has a very large, wide depth of field. You can see the person in focus and all of the stuff behind them in focus. Knowing what depth of field is and how it applies is important when you are deciding what type of video you want to create. If you're being more creative and you're trying to tell a narrative and focus in on a subject, a shallow depth of field is important. If you're trying to get as much of an event as possible, wide depths of field are important. So another element that sort of comes along from photography, and another thing that's important to know when it comes to using your camera, is gain. So gain is the electronic process in the camera that changes the amount of light that the sensor in the camera is able to absorb. When we used to do video with film, different types of film had different sensitivities of light. The chemicals in the film were able to be more or less sensitive to light. And that measurement of how sensitive the film was measured by something called ISO. ISO and gain are interchangeable terms when it comes to cameras because the concept is the same. ISO was connected to the film. Gain is connected to a camera's ability to make adjustments in a sensor. The effect of ISO, or ISO as it's sometimes called, and gain is very similar. When you increase your gain, the camera is able to see in darker light. And you'll be able to see in darker light without making adjustments to your iris. But the equipment adds electrical noise to the video. It sort of looks like a weird type of static. And that can be acceptable in situations where it's dark, you've got no control over it, but you need to get your subject. You need to make sure that people can see this at home. Having a little bit of that noise in the video isn't disruptive if that's what the video needs. But if you can control it, you want to turn the gain down because it makes less noise, your colors are clearer, and the balance of things is a little bit better. But again, you've got that balance off where gain that's lower works poorly in low light. It's a concept that can be a little bit challenging to figure out and how that relates to all of the other concepts I mentioned before. So now I'm going to turn to a photography pro who's going to talk to us about ISO. And remember, ISO and gain are the same. When he says ISO or ISO, the concept of gain, insert the word gain and you understand the concept. So this is Jared Polin of FronosPhoto.com talking about ISO and how it affects the look and function of photo and video.
Now let's take it back to the film days. They used to say if you're going to be shooting in bright light, you want to use a slower speed film. So you could get away with using 100 ISO, 200 ISO if there's a ton of light. As you lose light, that's when your ISO starts to go up. The more it goes up, though, the more you're going to introduce what we call noise or grain. Let me show you what this looks like. I'm going to take one picture at a low ISO and one at a higher. So let's take a look at the lower ISO. There's one. And let's switch this up and get to the higher ISO and see the results. Boom. There you go. So what you can see right here is in the lower ISO image, look how colorful, look how smooth the out of focus area is. Look at the shadow areas. Shadows are where you start to see a lot of the noise / grain. Now when we switch over to the super high ISO image, you see it has a more muted color look because the higher the ISO goes, the more color you're losing. The dynamic range goes down. Also, you're introducing a lot more noise and grain, so you're not getting a cleaner image. So that's understanding ISO as it pertains to noise. The lower the ISO, the cleaner the image. The higher the ISO, the less clean, the more noise and grain you're going to introduce. But let's also look at ISO as it pertains to subjects you're shooting, because ISO is one part of that exposure triangle. As I change the ISO, that's directly affecting how my shutter speed is going to be. So if I'm trying to shoot a moving subject at a slow ISO in a low light situation, my shutter speed's not going to be fast enough and that person may blur. So in this situation, you bump the ISO up higher, which in turn is going to raise your shutter speed and allow you to hopefully freeze motion. So that's a rule of thumb to keep in mind. If you're shooting a subject that's moving, you may need to have a higher ISO, but keep in mind, if it's ultra bright outside, you may still be able to get away with a lower ISO when shooting a moving subject.
So we've talked a lot about photography and applications that apply to both video cameras and still cameras. I want to talk a little bit about settings that are really important specifically for video cameras. And the big one that applies here is the concept of white balance. So in order to have video work in the early days of video and televisions, they realized that the range of colors that a CRT monitor could replicate was not as wide and as broad as the actual visual spectrum that human beings can see. It's actually a small chunk of the color space of all of the spectrums of light that humans can see. Technology has improved this, but it hasn't eliminated this. So when a camera sensor is taking a look at images, it can sometimes have a difficult time exactly replicating colors as a human eye would understand them, because it's trying to use a much smaller color palette than the human eye does. To compensate for that, cameras use something called white balance. We can program a camera by setting its white balance to create a baseline color, tell the camera what white is, and allow the camera to then see the rest of the colors that it's trying to get from that white reference point. This is important because the human eye doesn't necessarily pick up on it, but the nature of different types of light changes the nature of the colors around us. When we're inside, the color of the light is different from when we're outside in the sun. So knowing those differences and knowing that the camera doesn't have that same broad range of sensitivity explains why we need white balance. To illustrate this, I have an image of what's called a color gamut. So it's a display of what human vision is capable of. That's what the big sort of swooshy triangle is. And then there's a black sort of cutout triangle in the middle. That black cutout triangle is the color range that a television that was in color in 1953 was capable of replicating. So you can see there is a huge range of colors, particularly in the blue and red spectrums, that the camera wasn't really able to handle. So figuring out a way to move that reference point and shift it around so that the camera could replicate the color white in a room would help that a lot. Now, again, modern technology has made that black triangle bigger, but it hasn't gotten rid of it completely. So we still need to make adjustments on our cameras and set white balance on the cameras. Setting white balance is based off of color measured in temperature Kelvin. So when you take an object and you begin heating it up, the temperature that it is in Kelvin units will dictate the color that it produces based on how hot it is. So cooler things are warmer, have more of a red tone to them, whereas hotter things have more of a blue tone. And a good way to think about sort of the difference is if you've had it explained that a campfire or a candle is usually in that sort of orange range because the temperature of that fire, while still very hot, is cooler than, say, the flames on a propane stove, which are blue. those are very hot, concentrated flames. So those colors, those flames are two different colors. Light ranges throughout that whole set of colors. Indoor light, for example, is around 3,200 Kelvin. Daylight is around 6,500 Kelvin. So when you are setting your white balance, very often you will see your white balance displayed in a number similar to that. And what it's communicating to you is the white looks like it is lit based on that color temperature. And so based on that color temperature, the camera will then balance all of the colors in a space. And that's why it's important, if you change locations, inside to outside, you re-white balance your camera. Again, a lot of modern cameras will make white balance adjustments on their own. But you may notice that some of the color differences are odd, or you may notice a shift in the color differences. That may be related to the white balance of the camera, and you may have to adjust it manually. There are also instances, such as studio and on-location productions, where adjusting the white balance manually so that all of the cameras shooting a subject look the same color is extremely important, because you don't want to be visually jarred by all of a sudden your colors changing in the same video production. Okay, so we're going to stop talking about the mechanics of the camera, and we're going to start talking about you, the camera operator, and how you can make adjustments to your video and control the experience of what people are seeing. The first element of controlling those aspects is knowing what the basic camera movement commands are. So when a camera operator is being directed by someone, either a director in a studio who is talking to you over an intercom, or someone who's standing next to you giving you advice as to how you're going to shoot a scene, they will give you instructions on how to move a camera around. Those instructions will use special TV words. The most common of those special TV words are pan and tilt. Pan is the special TV way of saying, take the lens of the camera and move it left or right. Tilt is the special TV word for move the lens of the camera up or down. Now, it's important to note that we're talking about the lens of the camera and not you, because in order to make your various camera movements, you actually have to do the opposite to the other side of the camera. So if I want to pan a camera to my left, which is over here, I have to move the back of the camera to my right, which is over here. So panning left requires me to push the camera right, and the same is true for the opposite direction. That's also true for tilting. If I want the lens of the camera to go up when I tilt up, I have to push the back of the camera down, and reverse. When I want to tilt down, I have to push the back of the camera up. Always think, when you're thinking about your camera commands, about the lens, the front of the camera. That's what you're doing in relation to those camera commands. Less commonly used commands that are helpful to know are dollying, booming or jibbing, trucking, and rolling. So those are all movements that don't involve the lens of the camera, but they involve changing the position of the body of the camera. Dollying is physically moving the camera forward or back in space. Trucking is left and right. Booming or jibbing is up and down. And rolling is twisting the camera. There are a couple movements that are important that are connected to the lens. So not things that you're physically doing with the camera itself, but things that you're adjusting with the camera controls for the lens. The first is zoom. We were talking about focal length earlier, and moving your frame of reference forward and backward based on the body of the camera. So zooming, moving closer or farther away from the subject without moving the camera at all. You're just adjusting the glass in the lens to change the focal length of your image. You can also focus. Focusing adjusts the distances of all of the lenses inside the camera to make sure that the subject that you're recording has the correct, is in focus and is in that focal length range. A neat thing about focus is that if you've got your camera and you're not physically moving it around, so you're not dollying and trucking, you're just going to pan, tilt, and adjust. Once you get your focus, you can zoom out, in and out, you can move the camera around, and the focus will not change on your subject. And that's related to the physics of all of the lenses. Once you've got them in position, the space that's in focus doesn't change. It's only when you reposition the camera in space that you'll need to focus it again. Again, focus is not something you think of a lot for modern cameras because a lot of modern cameras will autofocus very often by tapping or selecting a subject for them to focus on. However, a lot of cameras that you will take into a mobile production allow you to specifically control your focus, both for creative reasons and for speed and control reasons. So the camera will not automatically focus. You'll have to manually adjust the focus. And knowing what that means and how to do it is important so that you can keep your image nice and clear the way you want it on the air. Or maybe not. That's a concept that'll come later, though. So you know your camera commands. Now let's talk about basic composition. Why composition is important is related to the nature of the human mind. We are constantly trying to make order out of chaos, figure out how all of the things around us apply to us and how to survive them all. And so as we are making order out of chaos, things that are already ordered are pleasing to our brains. Proper composition plays into that part of human psychology and physiology by creating order and establishing a logic to an image that's been created. Proper composition is important because when you have a video that's properly composed, the viewer will subconsciously consider the content of the video to have more order. They'll see that the person knows what they're doing. They will implicitly, if only a little bit, trust the content that's being created a little bit more. Whereas the composition is poor, the brain will see it being chaotic. The person won't necessarily be interested in the content that's being shared. Or they will just a little bit be less inclined to believe the content is credible. So it's important when you're creating your video that it is well and thoughtfully composed in some fashion. The easiest and the fastest method of composition, because there are lots of composition theories, but one that we use a lot in video is the rule of thirds. The rule of thirds, as displayed on the screen, cuts a piece of video up into vertical and horizontal thirds, all sort of 9 chunks of a piece of video. Generally, the composition of a piece of video relies on the places where those thirds intersect. So you generally will want someone's eyes, an area that we want to focus on, to be on that upper third line. If they're looking off into the distance or towards someone, you want them to be on one of the cross sections of those lines so that there is space for them to look into. If they're looking directly into the camera like I am, my eyes are in that sort of line between the upper and middle thirds. This is important in video because of the way the composition works. You're drawing attention to those thirds. There's order so that when I'm looking at it, I know where to focus and where not to focus. And it can be hard for someone who's picking up a camera for the first time because humans don't adjust our images like this. We look for eyes. We want eye contact. So when we look at a person, very often we're looking at their eyes and there's a bunch of unused space over their heads. So it's normal for us to look at someone and see a bunch of space. But when you take an image and put someone's eyes in the middle of the image, all of a sudden there's space and it's disruptive and it's confusing and you don't know why it's wrong, but it feels wrong. The rule of thirds is part of that. And one of the aspects that you'll notice that as we've gone through all of this is now that you're learning sort of the bits and bobs and how to make video work, we're going to start ruining how you watch video because you're going to notice how they compose things. You're going to notice how the video was recorded and how the elements are made and if a mistake was made or if something was really done nicely. So I apologize for ruining television and film for you now. But it's important when you're recording to be thinking about that rule of thirds. Another element of the rule of thirds is the lower third, the section that generally doesn't have anything important in it. That's a space that we use for graphics. We will put information about a program that you're watching or the subject that you're listening to in the lower third because it's a place where people aren't expected to focus. There's nothing important happening, but they can reference it if they need more information, and that information can be provided. When it comes to applying the rule of thirds, there are a couple of sort of camera commands and concepts that will come up. So I have a diagram here of a person who is properly composed. You'll notice their eyes are very close to the crosshairs of one of the splits between the upper third and the right third. And their eyes are in that focal point area. Directors will very often talk about headroom and look room. Look room is sometimes called nose room. Those are the amount of space on the camera that is provided between the top of the frame, the place where the video cuts off, and the subject. Headroom, you want to have a little bit of headroom. You want their head to exist in space. You want to see that there's something behind them. So having a little bit of space above them is appropriate. Cutting their head off looks unnatural. But too much space above them, as we discussed, looks weird and disruptive. So you want to control your amount of headroom. You also want to have space for them to look. So if someone's looking directly at the camera like I am, there's not a lot of space in front of them. But if you were to take them from a profile and have them looking at a host or a guest, you want space for them to be looking into and for their nose to be going into. And that is the concept of look room or nose room, space in front of their face to allow you to settle their eyes into one of those third focal points in the upper section. You also, when you're composing your shot, want to make sure that your background is not disruptive as much as you can. If you have control over your background, great. If you're doing an event and the background is chaotic for some reason, there's not a lot of control that you can do over that. There are ways to adjust that, such as depth of field. You can have the space behind the person be out of focus so that it can be as distracting as it is, but it's less something that someone is focused on because it's blurry. All sorts of fantastic tricks that you can begin to apply when you learn one of the many elements that we have at Pittsfield Community Television to do studio production, mobile production, field production with camcorders. All of the elements that we've discussed in how to make video work and how it works and why it works are important for you to know so that when you get into an applied situation, you can understand when the people around you start throwing around big words, what those words mean, why they're important, and how you can apply those concepts if there's not a member of the Pittsfield Community Television staff or experienced volunteers nearby to explain it to you. So I hope this video has been helpful. I hope it's given you a little bit of background on how video works, its history, and all of the things that go into making a proper video image. I encourage, if you're interested in any of these concepts, to continue your exploration into how it is and why they work. Even though this video is about an hour, it only scratches the surface of all of these concepts. So if it's something you're interested in, I encourage you to dive in. If you're not as interested in all of this stuff and you really want to get into the field and get your hands on things, that's where Pittsfield Community Television staff and experienced volunteers can start helping you get started. If you have any questions about this video or are interested in taking the next steps into being a Pittsfield Community Television member, volunteer, and engaged part of our community, I encourage you to direct all of those communications to me at engagement@pittsfieldtv.org. I once again thank you for taking the time to watch this video and spend some time with me learning. I hope it was helpful, and I look forward to seeing you in a future session. Take care.